Okay, so question 1. The equation of a straight line is y equals 4x plus 7. A, write down the gradient of the line, and B, write down the y-intercept. So if we remember, the equation of a line is y equals mx plus c, m being the gradient, and c being the y-intercept. So if we take a look at what we've got m as 4, so the gradient is 4, and we've got our y-intercept as plus 7, so we can write plus 7 or just 7. Okay, question 2. Here are the ingredients needed to make 8 shortbread biscuits. Tariq is going to make some shortbread biscuits. He has the following ingredients: 330 grams of butter, 200 grams of caster sugar, and 450 grams of flour. Work out the greatest number of shortbread biscuits that Tariq can make. So if we copy down the ingredient list here, so this ingredients list here makes 8 biscuits. So we've got 120, 60, and 180 grams. Okay, and this is responsible for 8 shortbread biscuits. So, being a non-calculator paper, let's see if we can manipulate these numbers. So we can double this. So if I then do 240, 120, and 360. Okay, so as I'm doing this, I'm looking at these values right here. Okay, and then seeing if they match up with these values here. Okay, so if I just get rid of that, I can then add another 120. So we've got 8 here. If I add another 120 to this, what's this going to be? 360. Add 60 to this, 180. And add 180 to this, which would be 540. So again, that would be another 8. So let's say, for example, these matched up. Okay. We would say we have 8, 8, and 8. So how many cakes can we make? 24. But if you have a look at the very first one, this would give us 360 grams of butter, but he only has 330, so we've hit the limit. Okay, the caster sugar is fine, but also the flour is not okay because he only has 450 and this requires 540. So what we can do from that point is now have a look at halving this. So this would give us 60, 30, and 90, and that would give us, this is important, 4 shortbread biscuits. Okay, now if we could use this point up to this point, so this would be 16 cakes, that would be 16 or biscuits. Let's see if we can add that and the 4. So if we add, so if I just write that here, 240, 120, and 360. Again, let's just label it butter, sugar, and flour. And if I add now the 60 from up here, so 60, 30, and 90, well, that would give me a total of 300 here, and then that would give me 150, and this would give me 450. So if I now compare these values, the 300 with the 300, well, that will be okay. There's still 30 grams left over. If I check the 150 with this would be okay. There's 50 grams left over. And if we have a look at this one here, 450, that is right on the limit of the flour. So because that's the greatest number of cakes that we can make, because we only have 450 grams of flour, that means it will be the 16 biscuits, which this provides, and the 4 biscuits, which this provides. So in total of 20 biscuits. Right, question number 3. Rail Tickets and Cheap Trains are two websites selling train tickets. Each of these websites adds a credit card charge and a booking fee to the ticket price. Nadia wants to buy a train ticket. The ticket price is £60 on each website. Nadia will pay by credit card. Will it be cheaper for Nadia to buy the train ticket from Rail Tickets or from Cheap Trains? So, two scenarios we've got here. Let's write Rail Tickets here, and let's write Cheap Trains here. Now it says the ticket price is £60 on each website. So 60 ticket and £60 ticket. So Rail Tickets, let's start with this one first. It says a 2.25% of ticket price charge. So we've got plus 2.25% charge plus 80p. Right, so the key piece of information you mustn't miss out on is this part here, which says of ticket price. And it again says here of ticket price. Okay, so that means we wouldn't be including the booking fee with our calculation. So if I just remove that now, and let's look at this. So we've got a £60 ticket. We need to work out the percentage. So 10% would be a £6 charge. Therefore 1% would be a 60p charge. Okay, now we need to get to 2.25, so another 1% will be 60p, and now we need to find 0.25%. So that would mean that 0.5 is 30p, therefore 0.25 would be 15p. So if we add that all up, we get a percent fee of £1.35. Okay, meaning so we have the £60 plus the 2.25%, which is £1.35, plus the 80p. So if we add this up, 5, 8 and 3, 11, carry the 1, 2 and 6, so £62.15. Now if we take a look at Cheap Trains, we've now got a £60 ticket, 1.5% charge, and a booking fee of £1.90. Okay, so again, if we find 10%, that will give us £6. Therefore 1% would be 60p. Therefore 0.5% is 30p. So we have a total there of 90p. Okay, so if we now do the addition, we've got £60 plus the 90p fee plus the £1.90. So 0, carry the 1, 18, 2 and 6. So if we look here, we've got Cheap Trains costing £62.80, and we've got Rail Tickets costing £62.15. So the conclusion will be obviously Rail Tickets is the cheapest, and you can also say by how much, so that would be by 65p. Right, okay, so question 4. The table gives information about the length of the branches on a push. Draw a frequency polygon to show this information. So we've got the length and we've got the frequency. So with a frequency polygon, we're going to go for the midpoint of all of these values. So let's go with 5, 15, 25, 35, 45 and 55. Now it's important to double check that, because sometimes the intervals are not necessarily a gap of 10. Okay, so don't get caught out on that. And then what we need to do is plot. So for midpoint of 5, frequency of 20, Let's go about here. Midpoint of 15, and we'd get 12. A midpoint of 25, and we get 10. Midpoint of 35, we get 8. Around here. 45, 6. Around here. And 55, we've got 0. Okay, so connecting that up. Obviously try and use a ruler when you do it. And that's that done. Work out the total number of branches on the bush. So we've got 20, 12, 10, 8, 6. Add these all up, so we've got 2, 8 and 6. We've got 16, 2, 1, 1, and carry the 1, so that's 5. So we've got 56. C, write down the modal class interval. So modal being mode, most common. Okay, the class interval being the range or the gap or the 0 to 10 and so on. So if we look here, which one has the highest frequency, and looking at this, we can see that the one with the highest frequency is the 0 to 10, and that has a total of 20. So our interval will be the 0 to 10. Right, so the expand and simplify. So be very careful not to use FOIL here, because these are not just double brackets. You've got a number on the outside. So I'm going to expand this one obviously first, and then this one second. So first I'm going to have, if you remember from the arrows, multiply each term. Okay, so that's going to give us 2x plus 6y for the first one, and for the second we're going to get, again showing the arrows, 4x minus 4y. Okay, so now if I combine these two together, not forgetting this sign here, the plus sign, we've got 2x plus 6y plus 4x minus 4y. So collecting like terms, let's deal with the x first. We will have 6x from that. Then we've got 6y, take away 4y, which will give us plus 2y. Okay, part B, factorise completely. 8p minus 12pq. Well, to factorise means to take out the highest common factor. Okay, that also includes letters. So if we just deal with the number first, the highest common factor of 8 and 12, well, that would be 4. So 4 would come outside. We then scan this expression for common letters. So we can see that there's a p here and a p here. You can also see that there's a q, but there isn't a q in this term here. So all we can pull out is the p. So I'm going to write 4p, and then once we've done that, we can open the bracket. Now what do I multiply 4p by to get 8p? Well, that would be 2. And what do I multiply 4p by to get minus 12pq? Well, that would be minus 3q. And we're done. Okay, and you can check this. So if we times this out, you'll get 8p minus 12pq, and this is the same as that. Question 6, find the HCF of 30 and 42. So I'm going to have my factor trees, 30 and 42. List them like that. So I'm going to go for 2 and 15. 2 is prime, so I'll circle it. 3 and 5, prime, prime, so I'm done. So I list in ascending order, 2 times 3 times 5. Here I've got 42, so I could do 2 and 21. 3 and 7, both prime. So 42 is done. So if I now list them under each other, I'll have 2 times 3 times 5, and then I've got 2 times 3 times 7. So now pairing these up, I've got a pair of 2s and a pair of 3s. So once they're paired, they're considered one number. So this is effectively 2 times 3. Therefore, my HCF is 6. Okay, next part, B. Find the lowest common multiple of 30 and 45. So lowest common multiple being the timetables. So what we can do is write 30, 45. So this would be 30, 60, 90, 120, and so on. Then we'd have 45, 90, and I can already see I've hit 90. So our lowest common multiple would be 90. So don't forget, multiple means multiple, so multiplication or the times tables. Okay, question 7. There are 9 counters in a box. 4 are red, 2 are blue, and 3 are yellow. Pravinder takes at random 2 counters from the box. Work out the probability that he takes at least 1 yellow counter. So if we got our starting point here, we're going to have something like this. Okay, and then we've got red, blue, and yellow. Okay, in terms of probabilities, we've got 9 counters in total. So this will be 4 out of 9. This will be 2 out of 9. And this will be 3 out of 9. Going again, we've got 3 choices. So we've got red, blue, and yellow. Red, blue, and yellow. Red, blue, and yellow. So listing the probability, if he's gone this route, it will be a red, so this will be 3 over 8. The blue will remain the same, so that will be 2 out of 8. And this yellow will also remain the same, so 3 out of 8. Next up, if he's gone for the blue route, so then we're going to have 4 out of 8. We're going to have 1 less than the blue, so it's 1 out of 8. And then we're going to have the same in the yellow, so 3 out of 8. And then finally the yellow, if we go to the yellow route, we're going to have 4 out of 8, 2 out of 8, and then we're going to have 1 less yellow, so 2 out of 8. Next up, what I can do is list the choices. So this first choice here will be red, 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 blue, red, yellow. Then we're going to have blue, red, blue, 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 yellow, yellow, red, yellow, blue, yellow, yellow. Now if we remind ourselves, it says at least 1 yellow counter. So anywhere where I see at least 1 Y, so I've got 1 here, 1 here, 1 here, 1 here, and 1 here. Now it says at least 1. So it doesn't say that they have to be different. At least 1. Okay, so now just write the fractions for each choice. So red, yellow, so that's going to be 4 over 9 times 3 over 8. This one here is going to be 2 over 9 times 3 over 8. A yellow red is going to be 3 over 9 times 4 over 8. And then we've got 3 over 9 again times 2 over 8. And then 3 over 9 times 2 over 8. So if I now put equals on all of these, I'm going to have 72 as the common denominator, because 9 times 8 for all of them. Okay, so then I'm going to have 12, 6, 12, 6, and 6. So now they're all the same denominator, which means I can add them. So if I write that down here, I've got 12 out of 72 plus 6 out of 72 plus 12 out of 72 plus 6 out of 72 plus 6 out of 72. So make sure I'm not missing any. I should have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, if I add that all up, it stays over 72. What do I get? I get 12, 12, and 12. 36, 36 plus 6 will give me 42. And if you want, you could show that working out. Okay, but 42 out of 72 is your final answer. Okay, question 8. Work out 2 plus root 3 times 2 minus root 3. Give your answer in its simplest form. So now we've got two brackets next to each other, so we can use FOIL. So against the first in each term, so 2 times 2, 4. The outside, which will be minus 2 root 3. The inside, which will be plus 2 root 3. And the last, which will be minus root 9. So if I put that all together, I'm going to have 4 minus 2 root 3 plus 2 root 3 minus root 9. So if I now look at that, we've got a minus 2 root 3 and a plus 2 root 3. Well, that's going to cancel out. So I'm going to be left with 4 minus root 9. And then, of course, root 9 is 3. So I'm going to have 4, take away 3, and that will give me 1. Okay, question 9. So this is a circle theorem question. A, B, C, and D are points on the circumference of a circle centre O. Angle AOC, so let's just mark that, angle AOC, which is this one here, equals Y. Find the size of angle ABC, so let me just get rid of that, ABC in terms of Y. So if you know your circle theorems, you should be able to spot two of them going on. So the first one will be this one, okay, the arrow, okay, and the second should be this one, which is the cyclic quadrilateral. Okay, so those are your two circle theorems that you should spot here. Now, if we go back to our first circle theorem, arrow, let's redraw that again, we know that the angle at the centre is twice the angle at the circumference. So if this angle here is Y, that means that this angle here is Y over 2. Okay, so let's say, for example, this is 40. That would mean that this angle here is 20. So we're just going to stick with the algebra, which would be, if that's Y, that would be half of it. So therefore it's Y over 2. Okay. So we've got this as Y over 2. We need to find angle ABC. Okay, and this is where our second circle theorem comes in with the cyclic. We know with a cyclic quadrilateral that the two opposite angles, so this angle here and this angle here, must add up to 180. So in order to find that, we're going to have angle ABC equals 180, take away the value of the opposite angle, so that's Y over 2. Okay, and it says find in terms of Y. That's our final answer. Angle ABC equals 180, take away Y over 2. Now, to fill this in with the statements and reasons in order to get our full marks, let's start off with the first, which was the angle at center, twice that of edge. Okay, and then this allowed us to find ADC. Okay, so angle AOC equals y, therefore angle ADC equals y over 2. Now with our second point, we have cyclic quadrilateral, and therefore angle ADC plus ABC equals 180. Well, we knew that angle ADC was y over 2, so we just substituted that as follows. And therefore from algebra to find this, we have y over 2 that we need to get rid of. So therefore ABC is 180, take away y over 2. Okay, so if we look at question 10, the diagram shows a sketch of the curve y equals sine x for 0 to 360. The exact value of sine 60 is root 3 over 2. Write down the exact value of sine 120. So if we look where sine 60 is, it will be somewhere around here, which will correspond to this area around here. Now, to find sine 120, if we look where 120 would be, it would also be around here. So that would give us exactly the same value. So the sine of 120 would be root 3 over 2. And it would be a positive because it's in this upper region. Which leads us on to the next part. What is the value of sine 240? If we look on the graph, 240 would be around here. So if we look at the value of sine 240, that falls in the same spot and is linked with sine 120 and sine 60. Therefore we'd get minus 3 over 2, and that's because it's in the lower region of the graph. Part B. On the grid below, sketch the graph of y equals sine 2x for 0 to 360. Now if we remember from transformations, this is y equals sine 2x. So this 2 is impacting the x. So if we take a look at the plot points above, we've got sine x, which is the original. So if I just look here, we've got sine of 90 at 1, 180 at 0, 270 at minus 1, and 360 at 0. So what I'd like to do is plot those points onto this graph. So if I'm going to say the value of sine 90, so let's say I would like to plot for this value right here. If I put x in, that would be me going y equals sine 290. But if I carry that out, that's actually the sine value of 180. So if I look at my original graph, the sine value of 180 is 0. So that 90 is now going to stay at 0. It's going to move. So can you see here in the original, sine of 90 was at 1. Here it's now at 0. So if I would like to plot here, for example, this would be 45. If I then put sine 2x and I put sine 245, this is actually the sine of 90. So if I can find the sine value of 90, that would give me what I should put here for 45. So the sine of 90 is 1. That means that sine 45 would be at 1 too. And I do this throughout the entire graph. So sine of 180 is 0. That means that I get my value for 360, which is at 0. So what you can see happening is everything squashing up. So this here, the middle between 90 and 180 would be 135. Well, 135 times 2 will give me 270. So I need to look at my value up here for 270, which is -1. And that means where I find 135, I plot a -1. So you should be able to see what's happened. I've got a graph that's doing this. So because it's sine 2x, it's actually doing 4 oscillations in one graph. So from the range of 0 to 360, we're now doing 2 cycles instead of just the 1. And this cycle would then repeat. Like so. So there's your 2 cycles in one. Okay, so question 11. Sketch the graph of f of x equals minus x squared minus 3x plus 5, showing the coordinates of the turning point, this is a key word, and the coordinates of any intercepts with the coordinate axes. So if I just draw an axis here, okay, we've got x, now y. Now we can see this is a quadratic, okay, because of the x squared. It's also a minus, which means it's going to be an upside down parabola. Okay, so it's a minus, and it's an upside down parabola. What we need to find are the points where it crosses the y-axis and intercepts the x-axis. So let's start off with the easy one, which is to find out where it intercepts the y-axis. Now, the value of x when it's on the y-axis is 0, because that's right here. So what we need to do is, if we get our equation, which is f of x equals minus x squared minus 3x plus 5, if we make x 0, so set x equal to 0, we've then got minus 0 squared minus 3 times 0 plus 5. Of course, all of this equals 0 except for the last part, which is plus 5. So that means at 0, 5, there's an interception point. So this is not to scale, but I'm just going to put a red dot here, and I'm just going to put 0, 5. Okay. Right. Next, what we need to do is find out the where it intersects the x-axis. So if I just rub this out just for some space, leave our equation right in there. So to find out where it intercepts the x-axis, we have to set y equal to 0. Okay, so now I'm going to rewrite this to minus x squared minus 3x plus 5 equals f of x. And now f of x is essentially y, but instead of f of x, I'm going to write y. Okay, and then instead of y, I'm now going to put that equal to 0. So I'm going to rub that out and put equal to 0. So now you should be familiar with that we need to solve this quadratic. And by solving the quadratic, we find out these points here. Okay, so this is non-calculator paper, so there is the quadratic formula we could use, and we could also complete the square. To make it slightly easier, what we can do is we can use the formula. So that would be minus b plus or minus the root of b squared minus 4ac all over 2a. Now a, b, and c. So if we look at a, we've got -1, b we've got -3, and c we've got a +5. So we just put that in a box there. Right, so filling this in, minus 3, so remember your brackets, plus or minus the root of minus 3 squared minus 4 times -1 times +5 all over 2 times -1. So if we now simplify this, we've got +3, because 2 minuses will make a plus, and then we've got plus or minus the root of, this will be minus 3 squared, which will give us 9. And then we've got the minus there. 4 times minus 1, minus 4. Minus 4 times positive 5 give us minus 20. Don't need to go that much. All over 2 times negative 1, which of course is just negative 2. So if I tie this up again, I've got plus 3 plus or minus the root of 9 plus 20 all over negative 2. So then I will get, so if I take care of this and this, plus and minus will make a minus, so therefore I can just put minus 3 plus or minus the root of 29, all of that over 2. And because this is minus 3 plus or minus, this can then go to negative 3 over 2, so I can split the fraction, plus or minus the root of 29 over 2. So I'm going to have two solutions. One solution I can just list as this and remove one of the signs, so I'm going to make this the positive version. For number 2, I'll have negative 3 over 2 minus the root of 29 over 2. Okay, so those are my two solutions. So the first one will be, say for example, here. And the next one will be here. Now I can just double check that. So this is basically minus 1.5 plus now root 29 over 2. So we won't know that exactly, but let's say for example it was root 36. That would be 6, and then half of that would be 3. So this would be, say for example, plus 3, just to give us a rough idea. Negative 1.5 plus 3 will give us 1.5. And if we do the same here, negative 1.5, and I'll still keep with root 36 because it's fairly close. That's of course root 25, which we could use, but let's just stick with root 36. Sorry, root 36. That would also be minus 3, and that of course would be minus 4.5. So this, by that, would be solution 2, and this would be perhaps a little unrealistic. Try and keep it in scale. Maybe perhaps something like here. Okay. So if we then look at drawing this parabola, we still need to find the turning point. So what we've got is we've got the intercept of the y, which is here, and we've got our two x-intercept points here, but what we need is the turning point, so the line of symmetry. Now if we remember, the line of symmetry is minus b over 2a. This is the line of symmetry, or our turning point. So we know that b is minus 3, so we've got minus 3 over 2 times minus 1. That will give us plus 3 over negative 2, or negative 3 over 2. So minus 1.5, so our turning point would be at negative 1.5. Now to find the y value, so remember this is the x coordinate, we'd need to substitute that in to the following. So then we've got minus x squared minus 3x plus 5, so negative 1.5 squared minus 3 times negative 1.5 plus 5. So that would translate to, just because I'm running low on space, we will have negative 2.25 minus 3 times negative 1.5, which will give you plus 4.5 plus 5. So then we've got minus 2.25 plus 4.5 plus 5, which will give you 7.25. So we've got an x coordinate of negative 1.5 and a y coordinate of 7.25. So if we look where that plot would be, say negative 1.5 is around here, and 7.25 would be around up here. So what we're going to end up having is a parabola that looks something along the lines of obviously that's not a perfect drawing, okay, because it should look like a parabola, but that's a good example. Now what we need to do to finish this off is to write our values. So up here I'm going to have negative 1.5 comma 7.25. That's for this point right here. We've got point 2, which is negative 3 over 2 minus root 29 over 2, and that's for this point here. We've then got negative 3 over 2 plus root 29 over 2, which is for this point here. And we've of course got the 0, 5. So that is what you need to do for question 11. So it's obviously quite a long length. Now, what I'd like to do is I'm going to show you another way which you can do it. So I'm just going to rub this out, and then we're going to start from the beginning again. It's just another way of doing it. So we're going to do the complete square method. Right, so if we take a look at this again now, we've got negative x squared minus 3x plus 5. Now let's do the complete the square method. So complete the square method is going to find our solutions. Okay, and this is of course for the x-intercept. So what I can do is just very quickly draw an axis. Of course here's our x and here's our y. We then again same trick, it's a negative, so it's going to be upside down parabola. So if we got negative x minus 3x plus 5, what I'm going to do is I'm going to times this by negative 1. So that means I'm going to change it to x squared plus 3x minus 5 equals 0. Now the reason I have to complete the square on this is because it's not a quadratic that can be factored. So how we can check for that is if we do b squared minus 4ac, and then of course if we list just up here a as 1 now, b as 3, and c as negative 5. We'll just put that in a box there. And if we just fill this in quickly, so b squared would be 3 squared minus 4 times a times c. So this would be 9 minus 4 times 1 is 4, and 4 times negative 5 is negative 20, so we're going to have 29. Now 29 is not a perfect square. And what is a perfect square? Well, a perfect square example would be 25. So a root 25 would give us 5. Another perfect square example would be root 36, which would give us 6, and so on. You have root 49 and so on and so on, which would give us 7. So because this number here is not a perfect square, means we can't factor it, therefore we have to use complete the square. So to complete the square, we're going to have x squared plus 3x. We're going to leave a gap. We're then going to move that minus 5 over to the right hand side, which is going to make it a plus 5. Now we need to find our magic number, and the magic number is b over 2 squared. So b is at the moment 3, so we're going to have 3 over 2 all squared. So we're going to add that, and then add that to this side as well. So then we're going to write this again. So we've got x squared plus 3x, and this is going to be plus 9 over 4, because 3 squared is 9 and 2 squared is 4, equals, and again 5 plus 9 over 4. Now this is the part that we need to factor. So to do this, we put this as x plus and then b over 2. So this is going to be 3 over 2 all squared, and now this left side has been factored, and now we've got the new right hand side. So that's equals, don't forget a number is always over 1, so if we add these fractions, make the denominator both 4, we're going to have 20 plus 9, and then we're going to have x plus 3 over 2 squared equals 29 over 4. Now if I move this all to one side, we'll end up with x plus 3 over 2 all squared minus 29 over 4 equals 0. Now, if you remember at the beginning, we multiplied everything by -1. So what I'm going to do is do that here. So I'm going to end up with x plus 3 over 2 all squared plus 29 over 4. Okay. Now what this part is going to do is give us our vertex, which is that turning point that we're after. Now you may notice that this is the turning point straight away, so we don't have to substitute. So we've got our top point as 29 over 4, which is 7.25 for our y, and then we've got negative 1.5 for our x. This is our vertex point. So that from the last graph was around here. Okay, so it's our turning point. And of course we can write that up there too. Negative 1.5, 7.25. Now again, same thing with our solutions. To find those, we get this, complete the square form. Here, let me just rub this out. And you should be able to see what this turns out to be. So if we then revert back to x plus 3 over 2 all squared equals 29 over 4. We take the square root, we then end up with x plus 3 over 2 equals 29 over 4, and we root it because we've got rid of this 2 here, which of course that then, just to right here, becomes x equals minus 3 over 2 plus and minus the root of 29 over 4. If we can simplify that, or root 29 we don't know, but root 4 we do. So we'll have x equals minus 3 over 2 plus or minus the root of 29 over 2. And then of course we can split this up to x equals negative 3 over 2 plus root 29 over 2, and x equals minus 3 over 2 minus 29, root 29 over 2. And these two solutions are exactly the same as the ones we got previously, so it's roughly here and here. And then our last one, which we did at the very beginning of the first example, which is find the y-intercept. Well, the y-intercept is when x is equal to 0. So if we look at our equation up here, and we set x to 0, the only thing that we are left with is the plus 5. So therefore, when x equals 0, y equals plus 5, which is around here, given that 7.25 is around here. And then our rough sketch would look something like this. Okay, and then again, you can mark your points here like we did last time. So that's two different ways of doing it. Very similar, complete the square and the quadratic formula. There are pros and cons to each. The quadratic formula, you can just substitute the numbers in, but then you've got a bit more work with multiplying decimal numbers when you had to put in the negative 1.5. This method here particularly, as long as you're good with fractions, it's not too much of a problem. So there are two solutions there that you can look at to use, and then decide which one may be best for you.